This video will talk about scales, and scales is something that's very important because when you're drawing in AutoCAD, SketchUp, Revit, whatever you're modeling or drawing, you're drawing it to the full scale. That's the real size, right? So if this house is meant to be 50 feet wide, then you're drawing 50 feet in AutoCAD. But when you want to export that into, let's say, a print or a piece of paper, you cannot fit 50 feet into a piece of paper, right? Unless that piece of paper is extremely long. But that's going to be pretty hard, especially as documents get bigger or the sizes of what you're drawing. So what can we do? We can scale it down so that it keeps the same proportions. So the difference between scaling and just sort of squishing it or making it fit is that the proportions are identical. When we're able to measure this, we know that this length is exactly as that, just at a different scale or at a different size. And so we can always go back from small to big and be able to find information needed. So scale is very important, mainly for exporting. So one of the methods and the most common methods of exporting it is for printing. So it could fit in a sheet of paper. But there's other ways or other things that it could be needed, such as physical models or 3D printing, whatever you are modeling. So the first thing we need to sort of understand, right? What are we sort of exporting out to? Is it for a piece of paper, or is it for an actual physical model? Right. So in this case, we can see this home, and it fits in the palm of a hand, but in reality, we know it's going to be a lot bigger. So scaling it allows us to bring it into smaller size and be able to see a lot of its components to really explore. So I want you to think about why would scaling a model, or why would doing a physical model in the scaled down version be helpful? There's a lot of reasons, right? You get to really explore its structure, really get to explore its form. Perhaps it also helps as a presentation tool you can show to clients, and so on. Okay, so now we understand that if we want to scale it down to a sheet of paper, perhaps it can help us for the construction documents and so on, and perhaps a physical model can also help us for presentations or even refining the model itself. So now, how do we really scale? In this, the first thing you need to sort of be familiar is with this table. These are different scales, and probably the easiest to understand is this one. They're all the same, but sometimes just full numbers just makes it easier. So this one or even this one. Basically what they're saying is whenever you measure that scaled down version, it's going to be the same as this. So when in reality your house is 50 feet, which is this, the small version is going to be 50 inches because every inch equals a foot. All right, so you can see how now 50 inches is a lot more doable than perhaps fitting 50 feet in there. But maybe 50 inches is still too big for you. Maybe you still need a 50 inch piece of paper, which it's a lot more doable than this. But as you go experimenting different, like half, then now it'll be 25 inches, right? And now we're getting closer to being something more doable, and so on. So as you sort of experiment or try out all these different scales, you sort of are able to know which one would fit depending on your output. And remember, this goes back to what your output would be. Are you printing on a piece of paper, or are you doing something more physical? And so understanding what is going to be your output is going to be important, and so that you can sort of see what scale fits best. There is always the possibility of scaling to fit, or even the possibility of just scaling it without a precise scale. But the reason I wanted to start out by showing these is this sort of the standards. It helps sort of become more standardized in the profession of architecture, and is one of the most, they're the most commonly used. But in reality, you could scale it to something that's not here, right? Because at the end of the day, it can still be proportionally scaled. But for now, we're going to work with these. And one of the reasons why we also work with those is because you might be familiar or probably already purchased one of these architectural scales. And you can see that the same numbers, the 3/4, the 1/4, the 3/16, all of those that we showed you previously, they're also mentioned, and they're also shown in that ruler, in the architectural scale. And so these are usually used when you're drawing and you want to draw in again in a sheet of paper, and instead of truly measuring so it won't, if you're drawing in a 8.5 by 11 sheet, it won't fit the whole house, right? So you can use this to sort of help you mark the length in a scaled version. But it could also be used for a physical model if you're able to really show that this is 3/16 or something like that. You're able to use this scale and measure this and know this window is this and this window is this. So having a standardized scale will actually help you in the long run. If for some reason you use a non-standard, or even if you do use it, this is what we call a graphic scale. And I think graphic scales are also pretty important, again going back to a physical model or even a printed sheet, because these are usually placed either on the sheet of paper or on the actual model. It can be printed and laser cut into the model or in the side of the model, and these show you that from here to here it's 3 feet, and then it's 10, and so on. So you can very easily maybe get a piece of paper or try to use your hands, or at least gives you a more visual representation to understand the size of your model. So let's say this is 3 feet, right? And you were seeing this, and you would know this is 3 feet, then you would know that this window is about close to 3 feet, right? So it allows you to quickly sort of understand, because what if we're imagining this to be, let's say, 20 feet, but in reality is 200 feet, and so on, right? It's important to know, not only scale it down correctly, but to help visually understand what is the scale being used. So these numbers are going to be important. So let's say that let's start. We're going to be using 3/4 in our case for today's example. And so in this case, so how do we use it? First, like I said, you will have to sort of use your scale. The second thing is knowing the scale factor or the inverse scale factor. We're going to use the inverse scale factor when we want to make it smaller. We're going to use the scale factor when it's already been reduced and we want to bring it back to its original size. So let's go with this one. Please write down this number so that you don't forget it, and we use it for today's examples. And it's 0.0625. We're going to start by making it smaller. So I'm going to show you in 3 different softwares. First, let's start with AutoCAD. So here in AutoCAD, I've already made a box, right? And let's make another box that's sort of 3 feet by 3 feet. There you go. So now when we measure this, we're able to know that this is 3 feet by 3 feet. So in AutoCAD, I'm able to select it, press, type in SC for scale, and it's going to ask to specify my base point. So I'm going to select this corner, it doesn't matter which one, and now it's asking for specify a scale factor. So it goes back to what we were just doing, inputting our number. So this number that was here, 0.0625, I'm going to input that into what I'm doing. So I'm going to write 0.0625. Now we're going to see, that I had done it previously, that now it brought this into 2 1/4. Right? So now we have this is a scaled down version. If I want to do the opposite, I would do 16. Right? So if I were to do this, scale, and I want to bring it back to its original, put 16, and there I should have my original. And same thing with this one, is the smaller version, so we're going to keep it just for reference. This is the same thing in SketchUp. So here I have SketchUp, and I'm going to make also a 3x3 box. There you go. I'm going to group this, make it to a group. And if we want to measure, we'll see that it's already 3x3. I'm going to select it. I'm going to press scale. I'm going to press the letter S for scale. Or you can also find it here with the symbol. I'm going to start dragging it. And you can see at the bottom right, it's giving you some numbers very similar to what we had done before. So we're going to go back with our number 0.0625 for 3/4. 0.0625. Press enter. And then I'm going to go back and I'm going to try to measure that one more time. And as I'm doing that, it gives me the same number. And if I were to do the opposite, which was 16, it should bring me back to my 3. So if I measure this, I'm able to come back to my 3. So this works. Obviously, be careful that when you're doing this, if I were to have many different things, I would need to select everything and then scale everything together, right? So be sure that you're able to sort of know that. Another option of scaling in SketchUp, so the first one you should use that one, but if for some reason there's a different version, this might help in some cases, you can actually use also the this tape measure tool. Select here to here. You're gonna click it and it's telling you that it's 3. But I know this for me is 2 1/4. So I typed it out. I'm basically telling SketchUp, I know this is 3, but I need it to be 2 1/4. I press OK. It's gonna say that's gonna resize everything, and so now it is, but it's over here and it's pretty small. But it was resized, right? In this case, it resizes everything, right? It resizes everything that you have. So so that's another another option that you can do. But in this case, it will not just resize this square; it would have resized everything that you have in your model. All right. So now let's do it in Revit. We open up Revit. Here already I have a wall. So I'm in first floor. I'm just creating a wall, and I'm just going to create a wall. This wall I want it to be 3 feet. Because we're using that 3 feet. In this case, it's not going to be a square, it's going to be more rectangular. I'm going to put some dimensions so you can see it. I'm going to select it, and using the same sort of idea we're going to use for scale, or the shortcut would be RE. And I'm going to say from this point, let's go back and do that. So over here, modify scale. And so select this scale. And you can see that there's 2 options. There is the graphical, which allows you more to do it more, selecting it. Or there's also the option, to numerical. And this goes back to what we were doing. So I had already inputted 0.0625, so I'm just going to select this as my starting point, and it will already move it. And you can see how it's already given me the dimension of 2 1/4. So it goes back to the same idea. In this case, it does have to be done sort of in multiple objects. So if I were to have, let's say, these 2, and then I really want everything to be scaled down, right? I would be able to, now this one was brought in a little bit shorter and so on, but you can scale everything to the point. Another option that you can do as well is also, if you feel more comfortable with AutoCAD, especially if depending on your output and everything that I've mentioned, and I do want to make this sort of important, that everything that I've been mentioning is for physical model. This whole video has been focusing on the physical model, because if I were to do this, and if I were to create a sheet here, and I would do this my first floor, and this, you can see how this already is telling me this is your sheet, and it has something at a specific point. So when it comes to paper, you can see it shows me a scale, so I can change this to any scale that I want. Let's say I'm just going to do a half. You can see how it'll change my actual size of this, right? So it'll actually be something that you can, it puts in there. But let's say I were to change this to something else, right? Let's do this. It'll change it into, now it's this. So when it comes to actually Printing, it's a different process, but everything that I've been mentioning is thinking of the output as 3D printing. So 3D printing or even laser cut. So speaking of laser cut, I do want to mention a little bit of that a little bit later on, but let me just bring it back to SketchUp. And so when it comes to SketchUp, um, remember when you're 3D printing, let's say I already scaled it down to whatever I needed to do. And the way to export it, all you have to do is File, Export, 3D Model, and you will select your STL file. You have to be sure that everything that's seen there is going to get printed. So let's say for some reason I want to hide this. Even though you press hide, it's still going to be detected as an object when you do STL out. So be sure to delete anything, create a new file, and delete anything that's not needed, right? So, and when we come to AutoCAD, it also has the option, right? If I were to select it, I can do STL out, and in this case, this is not a 3D solid object, so it won't really let me, but it'll be the STL out option. So now let's focus a little bit on laser cutting. So for laser cutting, again, I've already scaled it down. And so this goes back to the idea of understanding your size of where you're going to be at the output. So in our case, we have two laser cut tables, one being 12 by 24 and one being 18 by 32. So let's say this is a piece, one wall that you want to laser cut individually. There's another wall, there's another wall, there's another wall. As you can see, I just copied it, but over here there's a line over here and a line over there, so there's two lines. So there's a couple of things I want us to do. So first, we're going to click select it all, and press overkill, and that's going to delete any lines that are overlapping. So now you can see that if I delete that, there's only one line. The second thing is understanding all these layers. So the machine is going to sort of select your things, and it's going to ask you, do you want me to cut this? Do you want me to trace this or engrave this? So in this case, I know that all my exterior lines need to be cut. So cut. I'm gonna you can either do the match properties or change these to the cut layers. And I want everything inside to be traced. It's not going to be cut. I just want, these are maybe some etching or something, some details that I want to be, so press trace. So by knowing the size of your table, you'll know that the whole house can be built. When it comes to 3D printing, there's different sizes for the sort of the printing table, and so you will need to know sort of what your printing base is. In some cases, it's about 10 by 10, could be bigger, could be smaller, and so it goes back to the same idea. If this were your model, right, would it fit inside this? And so this is where you sort of start to explore your scale. You can even sort of cut into pieces your model so that maybe things are then you can build it together later on. Even the same thing with laser cut, you can sort of fill it out and so on. Right? So this was just a quick understanding of what scaling is, and to sort of get it ready for laser cut and also getting it ready for 3D print. So for 3D print, like I mentioned, you bring it in, you do STL out. And for this one, for laser cut, what you would be doing, you would press Control P. You're gonna have to select it, and then we'll able to sort of just select this window, and whatever's inside this window is what's gonna get laser cut. So this edge is the edge of the table, so everything has to fit inside this table. So be sure that everything that you are designing can fit in your output. In this case, it's not going to be a piece of paper. It's either going to be a table for laser cut, or it's going to be a 10 by 10 base for 3D printing, or a different base size depending on what you're working on what machines there's available. But you need to scale it down, be sure that it fits, and you can already to export. All right, thank you for watching.